All right, let's start out with our polynomials review for the test we have coming up on Wednesday. Let's jump right to it with number one. Uh, this is a topic we haven't really discussed in a while. This is just adding like terms. We got a trinomial over here plus a trinomial over there. We add the like terms together. With the m's first, we got 3 and -2, gives me 1m. The n's are next. I got a negative n, negative 3n is minus 4n. And then we look at our constants, the non-variables. 4 minus 5 is minus 1. Another one, we have x, number 2. X squared and x are not like terms. Even though they have the same variable, there's a squared on the first one, the first power on the 8 here. Those are not like terms. So we can only combine the 4x squared and the 5x squared, which is 9x squared. The 8x and minus x combined to give me plus 7x. And then plus 1 minus 1 cancel out, and we're left with just what we have there, 9x squared plus 7x. Where this gets a little tricky is when you subtract. We are subtracting this whole thing, each one of those. So subtract that, and subtract that from this first trinomial. So you could sort of think of it as 4x minus 5x, 4x squared minus 5x squared, 8x minus negative x, 1 minus negative 1. Or look at that as a negative 1 and distribute it. Negative 5x squared plus x plus 1. Now we can just add the like terms together there. So I have 4x squared and negative 5x squared gives me negative 1x squared. 8x plus x is 9x. Plus 1 is plus 2. Number 4, subtract 3x squared minus x plus 7 from 5x squared plus 4x minus 9. I will warn you, you will have a test question exactly like this. Make sure you understand the wording here. We're subtracting this from that. So if we set this up as a multiplication problem, think if I told you to subtract 2 from 5. It's not 2 minus 5. It would be 5 minus 2. It kind of switches around. So we're subtracting this from that. So we start with 5x squared plus 4x minus 9. And we're subtracting 3x squared minus x plus 7. We're subtracting that whole thing. So 5x minus 3x, 2x squared. 4x minus negative x is 5x. Negative 9 minus 7 is negative 16. So there's our answer. Number 5, we're just simplifying. Looks like some distribution, some like terms to combine. So 2y times y, 2y squared. 2y times negative 7 is negative 14y. Negative 3y times y, negative 3y squared. Negative 3y times 5 is minus 15y. Combine our like terms. 2y squared minus 3y squared is negative 1y squared. Minus 14 minus 15 is minus 29y. So there's our simplified version. Multiplying polynomials. This is FOILing here. Multiplying 2x minus 5 times x plus 7. We'll go with our first. 2x times x is 2x squared. Outside, 2x times 7 is 14x. Inside is negative 5x, followed by the last, which is minus 35. Combine your like terms in the middle. 2x squared plus 9x minus 35. Number 7 doesn't look like a FOIL problem, but we're multiplying this 4x plus 1 times itself. So if you set it up like that, it looks more normal. Then you can follow through with the FOIL step. 16x squared plus 4x plus another 4x, combining those steps there. And then the last 1 times 1 is plus 1. So there's that. Here we have a, oh, what did that little deck toys call it? A superfoil. We take the x, distribute it to all three. That's x to the third power plus 4x squared plus 2x. Then we take the 3 and distribute it. So we have plus 3x squared plus 12x plus 6. Then we combine like terms. We got x to the third plus 4x squared and 3x squared gives me 7x squared. 2x and a 12x gives me 14x. And then the plus 6 at the end. So, final answer. Find the area of this rectangle. We know area is length times width. So I'm just multiplying 6x times this bottom trinomial here. I'm going to set that up like a distribution problem. 6x times x squared is going to be 6x to the third. 6x times negative 2x is negative 12x squared. 6x times 8 is 48x. Times the width. Factor completely. So, factoring here, that is our X box. Giraffe and penguin worksheets there. Remember, we have the hard type, the easy type. Make sure you know which one you're doing. Starting out with a 3x squared, which is the hard type. So, 3 times 2 goes up top, negative 5 down bottom. We need to think of the two numbers that multiply to be 6. Add negative 5, which is a negative 3 times negative 2. So we set up our factors, the wrong factors to start with. 3x and 3x because of my a value there. Minus 3 and plus 2. And then we make it right. That one can be simplified by dividing by 3. So x minus 1 times 3x plus 2. Number 11, there's an easy type because it's plain x squared. So negative 10 up top, negative 7 down bottom. We have nope, can't be 5, can't be 2. This one does not look to be factorable here. 5 and 2 are the only things that can get us 10 and sort of 7, but there's no way I can make the negatives and positives make it negative 7. So we call that one prime. Number 12 looks to be a hard type. I notice that 2, 20, and 42 all have a common factor of 2. Factoring out a GCF of 2, that leaves me with x squared plus 10x plus 21, which is now an easy type. So 21 up top, 10 down bottom, 7 and 3 are my side numbers. So x plus 7, x plus 3. Okay, number 13, we have a hard type. 3 times 6 goes up top, 18. Negative 8 goes down bottom. Side numbers here, I'm thinking for 18, 1 times 18, 2 times 9, or 3 times 6. None of those can add to give me negative 8. So nothing can go in there. This is another prime one. So, non-factorable. On number 14, a rectangle whose area is x squared plus 6x plus 8. Remember, area is length times width. We need to figure out what the length and width are. So we're turning the trinomial, the area, into length times width. That's just a different way of telling you to factor this problem. So factor that trinomial. It's an easy type. So 8 up top, 6 down bottom, 4 and 2 on the sides. That leaves me with x plus 4 and x plus 2. That's your length and your width. The order you have those in doesn't matter, so that could be our width and that could be our length, either way. Those are the dimensions of this rectangle. Number 15 on the back, we are solving now. That was the, what animal was solving? Sheep. So, we took separate notes over solving. Start out by making sure it equals 0, which it does. Once it equals 0, we factor. It's the easy type, so 30 up top, 11 down bottom, 6 times 5 are the side numbers. So, x plus 6 times x plus 5 equals 0. I know that either x plus 6 is 0 or x plus 5 is 0. So, since that first binomial times second binomial multiply to be 0, then one of those multipliers has to be 0 itself. So, if you solve these two equations, you're going to get negative 6 or negative 5. Those are your final answers. X could be either one of those that would make that trinomial be 0 at the top. Number 16, it doesn't equal 0, so I need to start out by making it equal 0. Add 12 to both sides, and we get x squared plus 7x plus 12 equals 0. And then factor it. Easy type. 12 up top, 7 down bottom, 3 and 4 are our side numbers. So x plus 3 times x plus 4 equals 0. Using the same thing we used over here, we set up the two factors to equal 0 themselves, and we're going to get negative 3 or negative 4. Those are our x's. Number 17. I'm out of space here, but I'll squeeze it in. Again, make it equal 0. Canceling out the right side. 3x squared minus 4x minus 12 equals 0. Factor it now. That's the hard type. So we're going to have negative 36 up top and negative 4 down bottom. What could that be? Well, we got 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Those are my ways of multiplying to get 36. Any of those add up to be negative 4. I do not believe so. So this one is not solvable. There are ways to solve this, but we haven't learned those yet. So for now, not solvable. Number 18. This is a unique one. There is one like this on your test, so hopefully you've made it to this point. If you recognize that there is a greatest common factor here, then you can factor that out. It's an x. They both have in common, so x times x plus 8 equals 0. That's the way we need it to be. That's saying that these two things multiply to be 0. So we already know our answer. Either x has to be 0 or x plus 8 has to be 0, which would make x be negative 8. So x equals 0 or negative 8. That would be the easy way of doing it. I don't expect you all to catch that because you haven't seen a problem like that yet. So, doing it your way, it equals 0. So all we have to do is factor it. It's missing the c value, the non-variable, the non-x. So that goes up top. That's 0, and 8 goes down bottom. Two numbers that multiply to be 0 and add to be 8 are 0 and 8. So x plus 0 and x plus 8 are our factors. Either x has to be 0 or negative 8, based on the two factors that equal 0. So either way you do it, same answer. Number 19, start out by making it equal 0, so minus 27 to both sides. 2x squared minus 3x minus 27 equals 0. This is a hard type, so multiply a times c up top, which is negative 54, negative 3 down bottom. Side numbers and multiply to be negative 54. 9 and 6. Negative 9 and 6. So, make the factors wrong. 2x and 2x. Minus 9 and plus 6. Now we got to make it right. There are no factors here. 2x plus 9. And I can factor out a 2 here. So x plus 3 equals 0. And now, if that binomial and that binomial multiply to be 0, we set each one equal to 0. 2x plus minus 9 equals 0, or x plus 3 equals 0. So, negative 3, solve this one, plus 9, divide by 2, I get 9 over 2. So there is our 2. Last one, number 20. It equals 0 already, so all I got to do is the x box. Negative 60 up top, negative 7 down bottom. Multiplies to be 60 and adds to be, or negative 60 adds to be negative 7. I'm thinking 60, 2 times 30, 3 times 20, 4 times 15, 5 times what? 12? And that looks like what it's going to be, 5 and negative 12. So, set up our wrong factors. 10x equals 0. We got plus 5 and minus 12. So, make it right now. That one, they have a common factor of 5. 2x plus 1. Here I have a common factor of 2. So 5x minus 6 equals 0. Then we set each factor equal to 0 itself. So make too many equations. 1 is 0. 5x minus 6 is 0. If I solve this, minus 1, divide by 2, we get negative 1/2. Solve that, plus 6, and divide by 5, we get 6/5. So who answers that? Last one, a problem you haven't seen yet, but you will see it Wednesday. There's your fair warning. Factoring can be used to help simplify fractions with trinomials in the numerator and denominator. So if we factor the top and factor the bottom, we can then simplify by canceling out any common factors we have. So I need to factor both. That's the first thing. So the top, I'm going to factor the hard type. So 30 and 11. That gives me, I think I've already done this problem, I feel like, 5 and 6. So if I make the wrong factors, I got 2x plus 5 and 2x plus 6. Make that one right by taking out my common factor. And I have, let's go back over here with it, 2x plus 5 and x plus 3. That's the top. The bottom, we're going to factor the bottom now. Another hard type, so 25 times 2, 50. 15 on bottom, that looks like 10 and 5 on the sides. So make it wrong with the 2x. 2x plus 10 and 2x plus 5. And then make it right over here. I got a common factor of 2 on this first one, so x plus 5. And 2x plus 5 has no common factors, so 2x plus 5. 10 is going out. Once we have factored both, we see that there is a 2x plus 5 on the top and a 2x plus 5 on the bottom. Those can cancel out. You're multiplying something by itself, so it's like reducing a fraction if you think about it. That leaves us with just these two binomials. So x plus 3 over x plus 5 is that final answer. So that is it. Nothing else. Make sure you know how to do that problem. You'll see it. Good luck.